Hello everyone. In the previous video we have seen binary search algorithm and its working with an example. In this video we will be looking into binary search implementation at a glance. So to have quick recap, binary search only operates on the sorted data. The first step is to assign the first element position as low and the last element's position as high. Then we need to compute the middle element's position by the formula low plus high by 2. Now once we get the middle element, we need to compare it with the element to be searched. If middle element equals to the element to be searched, then we need to return the position and stop. If the element to be searched is greater than the middle element, that means your element to be searched is lying on the right hand side of the middle element, so we need to make the low as middle plus 1. Otherwise, if the element to be searched is lesser than the middle element, then it means that the element lies on the left hand side of the middle element, so we need to make high as middle plus 1 and repeat the same process. Now let's have a look at the implementation of binary search in Python language. So first I'll be defining a function named binary search. This function binary search is going to take two parameters. One is the array and another one is the element to be searched. Variable ARR denotes the array and element denotes the element to be searched. Now I will be defining any random array. Make sure your array must be sorted, otherwise binary search won't work for it. Next, I have called the function binary search with the parameter array and the element. Now let's say we need to search for the element 100 which is present inside the array. So I have declared a variable element. In that I have stored the value 100 and I have passed that variable in the function named binary search. Next, I will be defining the logic for binary search algorithm. So if you remember, first step is to declare the low and high position. So I have declared low variable and I have assigned the value 0 to it because the first element's position is always 0. Next, I will be defining a variable high. Now this variable high will contain the last element's position. To get the position of the last element, we need to first find the length of the array with the function len. Once we find the length of the array, we need to subtract it by 1 because array indices starts from 0. Next, I have defined a while loop which will iterate over the array. Now I have defined a condition low less than equal to high. This will keep a track of the low variable value. If the low variable value exceeds the high variable value, then this while loop will stop executing and return that the element is not present inside the array. Now if low is less than or equal to high, then inside the while loop I have defined a variable named middle which will store the value of the middle element's position. Now to get the middle element's position, we will write a formula low plus high by 2. I have used a floor division here to avoid any unnecessary decimal values. Now once I compute the middle element's position, I will check with the condition that if the middle element is equal to the element to be searched, then obviously the element will be found and therefore I'll be returning a value that the element is found at index middle because the variable middle will store the position. Now if the middle element is not equal to the element to be searched, then there are two possibilities. First is that the element to be searched is less than the middle element. Now just imagine if the element to be searched is less than the middle element, that means your element to be searched is lying on the left hand side of the middle element. Now in that case, you will keep your low as it is, but you will make the high variable as middle minus 1 because when you make it middle minus 1, the binary search algorithm will work for the left hand side of the middle element and it will try to search in the left hand side. Now in the else case, your element to be searched is greater than the middle element. That means your element to be searched is lying on the right hand side of the middle element. So you will make low as middle plus 1 and you will keep high as it is. and then the binary search function will operate on the right hand side of the middle element. Now if in the entire process the element is not found, then we will return that the element is not present inside the array. So to summarize, first we have defined the position of low and high value. Then we have computed the middle element's value. We have checked whether the middle element equals to the element to be searched. If yes, then we have returned the position. Otherwise, we have made the high as middle minus 1 if in the case element is lesser than the middle element. Otherwise, if the element is greater than the middle element, then we have made low as middle plus 1. Now let's execute the code and see whether our code is able to search the element 100. So yes, the code has given us the output as element found at index 8, which is exactly correct. Now let's search for any other element which is not present inside the array. Let's see whether our code is able to handle that situation or not. So let's take the element as 12 and let's execute the code. So you can see the output is displayed that the element is not found inside the array. So this is how binary search algorithm is implemented. You can find the code for this in the description box. Post your queries and suggestions in the comment box. Your suggestions are always welcome. If you like my videos, please like, share and subscribe to my channel for more such videos. And lastly, thanks for watching.